Welcome to this explainer. If you've ever felt completely overwhelmed walking into a physics lab, or maybe you're just unsure how a bunch of practical experiments actually connect to your final Cambridge IGCSE grade, well, you are exactly in the right place. Today, we're unpacking exactly how to use your practical skills workbook to absolutely conquer those 2023 exams. Think of this workbook as your personal roadmap. It's not just a place to scribble down numbers, it's a tool designed to systematically build the exact practical skills the Cambridge syllabus demands. So let's dive right in.
Here is our agenda for today. We're looking at 5 key steps: navigating syllabus content levels, essential lab preparation, executing the practical safely, recording and analyzing data, and finally, pushing beyond core syllabus requirements.
Part 1. Navigating syllabus content levels.
Okay, take a look at this layout. It's actually a brilliant visual trick to show you exactly what you need to study. The core content, the foundational stuff everyone needs to know, is just in your standard text format. But, and this is key, anytime you see a distinct, lined box drawn right around the text, like you see on the right there, you instantly know you're dealing with supplement investigations. It's such a simple, elegant visual cue. It literally keeps your study sessions highly targeted, so you aren't wasting time on the wrong material.
Let's jump to Part 2. Essential lab preparation.
Before you even touch a piece of equipment, every single investigation in the workbook starts by setting the stage. It gives you a brief context, explicitly explaining how the science you're about to do ties into the wider physics syllabus. It hands you the key terms, the relevant equations, the ultimate aim of the practical, and a suggested list of apparatus. Now, keep in mind, your teacher might swap out a piece of equipment here and there, but this core structure ensures you never ever walk into an experiment blind.
Right, so here is the absolute most crucial point: safety protocols. Before you even think about grabbing that beaker, you have to complete these 4 critical steps. First, read and actually understand the safety guidance. Second, carry out a risk assessment for your specific workspace. Third, make sure that workspace is safe. And fourth, and this is non-negotiable, you must get your teacher's green light before you begin. You need their explicit approval to start the method.
Moving on to Part 3, executing the practical safely.
I know this sounds incredibly simple, but reading this step-by-step method all the way through at least once before starting is the secret to avoiding those massive mid-experiment disasters. The workbook explicitly warns you about this. If you just read Step 1, do Step 1, and then look at Step 2, you completely lose the big picture. Reading the whole thing ensures you know what's coming, which stops you from missing out on crucial, time-sensitive steps when you're in the thick of it.
Now, as you're actually doing the experiment, the book gives you these great sequential instructions. But here's what you really want to watch out for: the embedded tips. The authors actually know exactly where students tend to mess up, so they've planted these specific tips right in the text to help you navigate the trickiest, most problematic parts of the procedure. Plus, you'll get constant reminders to work safely throughout the whole process.
All right, Part 4. Recording and analyzing data.
Okay, so your experiment is complete. You followed the method, you didn't break anything, and you've got a page full of numbers. But what do those results actually mean? How do you take that raw, messy data and turn it into the kind of meaningful physics conclusions that are actually going to score you marks on the exam?
This is where the workbook is a total game changer. It gives you clearly laid out sections to record your real-time observations and immediate results. But it goes way further than that. It pairs those observation spaces with scaffolded questions. These questions are literally designed to hold your hand and guide you, step by step, toward developing scientifically sound conclusions. On top of that, there are prompts asking you to evaluate the experiment's success. Like, did it actually work? And if it didn't, why not? That right there is the absolute core of scientific analysis.
Finally, Part 5. Beyond core syllabus requirements.
For those of you aiming for those top-tier marks, some practicals have these going further sections. These are incredible stretch activities. They throw additional questions at you that force you to take the theory you just proved in the lab and apply it to entirely different real-world context. These exercises purposefully push past the standard syllabus requirements to truly test if you conceptually understand the physics.
And to make absolutely sure you are ready for exam day, the back of the book is an absolute goldmine. It is loaded with actual past paper questions, and the best part, they aren't just random. They directly relate to the specific practicals you just finished in the workbook. It's essential exam practice that your teacher might set you in class or use later on for revision.
Now, a quick heads up. Don't go flip into the back of your copy looking for an answer key. To make sure you're actually doing the hard analytical work yourself, the answers to all the questions are kept securely locked away in the accompanying Cambridge IGCSE Physics Teacher's Guide.
Your teacher will walk you through the correct solutions when the time is right.
So let's look at the big picture. This timeline perfectly summarizes the journey the workbook takes you on. It builds a complete cyclical learning system. You start with pre-lab preparation, move into practical execution, transition into scaffolded analysis, and cement it all with targeted exam practice.
By using this highly structured approach, you're doing so much more than just memorizing facts for a test. You are genuinely learning how to think like a physicist. So, armed with all these tools, how will you use them to uncover the hidden physics in your next investigation? What are you going to discover in your very first experiment? Keep that curiosity alive, and thanks so much for joining me on this explainer.